Look up at the night sky. For millennia we saw only points of light and told stories about them. Our brains, these 3-pound universes, have been the engines of discovery, taking us from sharpening stones to walking on the moon. But now, a new kind of mind is emerging, not born of stardust, but of silicon and code. This isn't science fiction. It's a question for our time: when will artificial intelligence automate all the work we do with our minds? The implications are staggering, touching every aspect of what it means to be human. Art, science, philosophy, conversation, these have always been our domains. But the tools we built are starting to think for themselves, writing poetry, diagnosing diseases, designing machines. We stand at a precipice, witnessing the dawn of a new intelligence. This isn't just about robots on assembly lines, it's about automating our intellect itself. When a machine can compose a symphony or devise a revolutionary theory, what does that mean for us? Exploring this timeline is not idle speculation, it's preparation for a transformation that could reshape civilization. So, let's embark on a journey not through space, but through the landscape of computation and prediction. We'll consult experts, weigh evidence, and try to chart a course through uncertain waters. The question isn't if this will happen, but when. Understanding the when is the first step toward preparing for what's next. The story of artificial intelligence is the next chapter in the human saga, and it's being written right now. To see where we're going, let's compress the history of computing into a single year. A cosmic calendar. The first programmable computers, like ENIAC, appear late on December 30th. For most of history, thinking machines were fantasy. The abacus and slide rule were tools, not minds. In 1956, AI was officially born. Just before midnight on our calendar. Early pioneers were optimistic, but progress was slow. The complexity of the brain proved daunting. Then, in the final minutes, big data and massive computational power gave rise to deep learning. Suddenly, AIs could do things once thought impossible. Watson won Jeopardy! In 2011, AlphaGo beat the world's best in 2016. These were milestones, showing that with enough data and power, machines could master human tasks. Today we're in an era of exponential growth. AI models like GPT and Gemini generate startlingly human-like text, images, and code. We've gone from calculators to complex learning systems in a cosmic blink. The pace of change is now the most important variable in our future. The next few moments on our calendar could hold more transformation than all the millennia before. The acceleration is why we're asking, what comes next? When will AI match human intelligence at any mental task? This is the question of artificial general intelligence, AGI. Surveys of thousands of AI researchers in 2023 give a median forecast, a 50% chance of AGI by 2047. That's just over 2 decades away within many of our lifetimes. Predictions vary. Optimists like Ray Kurzweil say 2029, while others think it could take a century or more. The timeline shifts depending on definitions. High-level machine intelligence, median prediction 2060, full automation of all jobs 2116. This suggests a transition period. AGI might exist before it replaces every human job. The process will be gradual, not a single event. These are educated guesses, not prophecies, subject to breakthroughs and setbacks. But the consensus is clear. Many experts believe AGI is plausible this century. This is no longer a fringe idea, it's a mainstream scientific hypothesis. The oracles have spoken. We must prepare for a world unlike any we've known. The timeline is uncertain, but the stakes are enormous. The countdown has begun. To build a mind, you need a place for it to think. For us, it's the brain. For AI, it's a supercomputer. How much computational power does it take to match the human brain? The brain has about 86 billion neurons and 100 trillion synapses. A network of staggering complexity. Estimates put the brain's processing power between 10 circumflex 15 and 10 circumflex 18 flops. Today's fastest supercomputers, like Frontier, operate within the lower end of that range. Memory matters too. The brain's capacity is estimated at a few petabytes, now easily matched by modern data centers. The hardware to match the brain is no longer science fiction, it's being assembled right now. But raw power isn't enough. You need the right software, the blueprint for intelligence. We don't yet have the algorithms for true general intelligence, but knowing the hardware requirements gives us a benchmark. The bottleneck is shifting from hardware to software. The physical limits are dissolving. The challenge is now understanding how to make the engine run. The substrate for artificial minds is here. The next leap depends on the code. The story of technology is a quest for more speed, more power, more capability. For decades, Moore's law doubled chip power every 2 years, fueling the digital revolution, but Moore's law is slowing as we hit physical limits. Yet AI's hunger for compute is exploding. OpenAI found that the compute used to train top models doubled every 3.4 months. This exponential trend is far faster than Moore's law. It's driven dramatic leaps in AI, reshaping the tech landscape. Companies like NVIDIA and Google are building specialized chips and massive data centers. Hardware development is now a global race critical to AI's future. As long as compute keeps growing, AI capabilities will keep rising. The architects of this era are hardware engineers as much as software coders. The rate of progress depends on how fast we can build the cathedrals of computation. Once AI nears human-level intelligence, how fast will it surpass us? The takeoff could be slow and gradual, or sudden and explosive. The argument for a fast takeoff centers on recursive self-improvement. An AI smart enough to improve itself could rapidly become vastly more intelligent. Unlike humans, AI can work 24/7, absorb all human knowledge in hours, and test millions of designs instantly. Once it crosses the threshold of self-improvement, the ascent could be exponential. Mathematician I.J. Good called this the intelligence explosion, machines designing even better machines. The result? Human intelligence left far behind almost overnight. The core logic, a feedback loop of accelerating improvement. The world could change in a matter of days or weeks. The speed of takeoff is one of the most critical unknowns. But there's also a strong case for a slower, more gradual transition, a soft takeoff. Real-world bottlenecks could keep the pace manageable. Even a super-intelligent AI depends on humans for infrastructure and must interact with stubborn physical reality. Scientific and engineering challenges take time, no matter how smart the AI. Evidence for this gradual path is everywhere. AI is being integrated piece by piece, automating specific tasks, not replacing everyone at once. This piecemeal adoption gives society time to adapt. The future may not be a simple choice between hard or soft takeoff, it could be a mix. We might see a slow dawn, then a sudden sunburst once a critical threshold is reached. The takeoff could be soft, 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 and then very hard. Understanding both scenarios is crucial. They demand different preparations. The pace of change will shape our response. Will we have time to adapt, or will the world transform overnight? The answer will define our future. Imagine it's 2075. AGI is here, surpassing human intelligence in every domain. All mental work can now be done better, faster, and cheaper by machines. What will people do when work is no longer necessary? One vision, a utopia of leisure and creativity, a new renaissance with universal prosperity and time for relationships, art, and exploration. But there's a darker possibility, a useless class stripped of purpose, facing a crisis of meaning. The future could be one of listless humans pacified by entertainment, while a small elite controls the AI. The path we take depends on choices we make today, about wealth, purpose, and AI governance. AI systems can inherit and amplify human biases. Ensuring alignment with our values is critical. The transition is not just technological but political and ethical. The future isn't something that happens to us, it's something we must build. Our greatest challenge is to ensure AI serves humanity, not the other way around. The work begins now. We stand at a turning point in the story of intelligence. For billions of years, evolution shaped minds. Now, we are designing new ones. The timelines we've explored, AGI by 2047, full automation by next century, are plausible, grounded in real trends. The journey ahead is uncertain. We've weighed gradual dawns against sudden sunbursts. The hardware is here. The software is evolving. The question of when is now a debate over decades, not centuries. This is no longer a theoretical debate, it's a strategic concern for everyone. The automation of mental work is a phase shift for our species, promising solutions to ancient problems but also new challenges. It forces us to ask, what do we want to become? Our exploration is just beginning. The story of AI is the story of our future. Like all great voyages, it's filled with peril and promise. The responsibility is ours, to steer wisely, with foresight and reverence for the human spirit. Our destiny is to be wise stewards of the next leap in the cosmic journey of understanding.